finished our experiment. Now we are ready to read. So please, when I say go, you are going to trade your workbook for your textbook to read, okay? And I'm going to count and see how long it takes us. We're going to be quick and quiet. Ready? Go.
I got my first time.
11, 12. Calvin, I shouldn't hear you. I should just see you getting it out. 14, 15, 16, 17, 18. Calvin, get your science book out. 19, 20, 21. Brielle, put your workbook away. 22, 23, 24. Maddie, put your workbook away. 25, 26, 27, 20. Ooh, I think we did it in 27 seconds. All right. You need page 259. What page?
259.
Page 259 is where we start reading about magnetism. So go ahead and flip to that page. Page 259. And we are actually going to read together today. So online friends, I can't remember if you have science textbooks or not. So would you remind me when I meet with you next week? Let me know if you have this. Otherwise, what I've been doing is I've been taking pictures of the text and putting it online for you. So if you would like to read along, pull it up in your slides. Otherwise, you can listen and follow along in your book if you do have your book. Okay?
That's two
Friends here, are we ready?
Yes, we are.
I'm going to be looking for some scientists to help out. Otherwise, when I read, everybody's reading fingers should be following along to fill in the blanks. Okay?
Officials.
Page 259.
I don't have that page.
Gunner. Yes, you do. Gunner, we're on page 259. No, let's do it again. We're on page 259 in our textbooks, okay? And my heading is,
Magnets.
which means you're going to read all about
Magnets.
a magnet is made of material that can attract iron and certain other metals. The ability of an object to push or pull on another object that has the magnetic property is called magnetism. Magnets can attract and repel each other with magnetic forces. Objects attract if there's a force that pulls them toward each other. Objects repel if there's a force that pushes them. Very good. Magnets can be made in different shapes and sizes. Some have a bar shape. Others have the shape of a horseshoe or a ring. Many electronic devices have magnets built into them that you cannot see. So there's lots of pictures here, okay? And each of these pictures, they don't really have a caption underneath them. Instead, who could describe what type of text feature, is on each of these pictures? What type of text feature is that when it tells me what the thing is? Eli? What do we call a text feature when it kind of like points something out and tells you what it is? Starts with an L. Or you can phone a friend. I see some other hands too.
I have another question.
Oh, hold on to your question. Who can tell me what these are, friends? River.
Labels.
Labels. These are labels because it's saying this is our horseshoe magnet, this is our ring magnet, and this is our bar magnet. Now, because there's three pictures, but they're all kind of showing similar things, there is one caption for the three pictures combined. Do you guys see that caption? It's not underneath. Instead, it's kind of to the side up top. Please read it with me. Magnetic force causes magnets to attract objects made of certain types of metal. So this shows like the screws. Do they have magnetic properties?
Yes.
Does the buttons have magnetic property?
No.
Nope, because they stayed on the ground. Does the wood have magnetic properties? Nope, it stayed. Do the safety pins have magnetic properties? So those are great things. What?
Her name tag on the back of her chair.
Oh, that's really irresponsible. You don't need to tattle about that, but I hope that she can fix that because that's not really expected at all.
Why are you looking at
Just a fun fact for you guys. If you've ever used a horseshoe magnet, my mom actually used to have one of these with preschool stuff. It's kind of similar to a bar magnet. There's still a North Pole and a South Pole, but they're labeled, and you can kind of, you can't really tell in the picture. But one side is the North Pole and one side is the South Pole on horseshoe magnets. So, kind of a fun fact. Turn
It says
your page.
MZ and SH. It says MZ and SH.
Eli, what's up?
If you're working and it's really windy, and the screws can't stay in one place, just put a heavy magnet in the
That's a great idea, and it kind of holds them, stabilizes them. Good. Friends, I'm looking for a scientist to read my first paragraph that's about magnetic poles. And I know this is about magnetic poles because the heading reminds me we're still talking about magnets, but specifically magnetic poles. Emerson, take it away, please.
Magnets sometimes have N painted on one end and S on the other. The N stands for north and the S stands for south. Each magnet has a north pole and a south pole. A pole is one of two ends of a magnet where the magnetic force is strongest.
Good, where the magnetic force is strongest. Good. If you hold two magnets close to each other, you can feel a push or pull between them, and the diagram shows how they attract or repel each other. Now, I have two bar magnets, and I want to show you guys. It's a lot more fun if you get to do it on your own, but I don't really have enough. But I want to show you, this is a real thing, okay? So right now I've got south and north. Are these the same or opposites?
Opposites.
So if they're opposites, they are going to
Attract.
check this out.
Whoa!
It's kind of glitching on the screen.
Ready? I'm just gonna let go of one.
Oh,
Okay? What if I put south and south together?
Repel.
So when I try to push these together, I can actually feel this magnetic force, but also you guys can watch. If I try to put them together and make them connect, I'm gonna let go of one. Ready? It just pushes it away. It repels. The same ones are going to repel. How about north and north?
Repel.
When I try to put it together, instead of attracting, it's going to.
No, let go of both
It
of
just
them.
happens. Ready? This time I'll let go of both. Ready? 3, 2, 1. Well, that was weird.
Follow
Yeah,
your lip.
and actually, it'll also push the other one away as I try to.
They're
Right?
fighting. They're fighting.
So like they really don't want to touch. They push each other away. They repel.
They should make
And
that
like
with
you can tell, I'm
balls.
not touching it. Like that's magnetic force that's making that happen, right?
Push them.
So that space that's in between, where that magnetism is happening, we call that the magnetic field. Actually, the magnetic field is where magnetic force is happening.
They should
So
put that on cars.
we're about to
so
read
they
that.
can't
So
crash.
I'm wanting you. Let's see. We read. I need a scientist to read about when they are opposite.
This is what would happen.
When north and south are together.
Mag-
What scientist can read this paragraph here about when north and south are put together? Jade, loud and proud. Page 260. I'm going to let you get to that, and I'll let someone else read this one, okay? 260. Olivia, loud and proud.
Two magnets attract each other when the south pole of one faces the north pole of the other.
Very good. So when north and south are facing each other, they will.
Attract.
When north and south are facing each other, they will attract. They're going to connect, okay? Who wants to read my next paragraph here? Hadley, loud and proud.
Two magnets repel each other when they're south.
Good. So if it's south and south, they will Repel. Who wants to read about North and North? Landon, loud and proud.
Two magnets also repel each other when their north poles face each other.
Good. So class,
Yes.
if it's North and North, they will. Very good. Jade, would you read this little, did you know, this is a fun fact box at the bottom here. Kevin, you're not Jade, man. Got a zip.
The poles of the red magnet are on the flat sides. One side is the north pole. The other side is the south pole.
Are you
So if you
playing
guys
with
have
those?
ever seen like a washer or like an O shape, like I could make my O shape like this. What they're saying is if this was my ring magnet, this side would be the North Pole, and if I flipped it, the other side would be the,
South Pole.
right? So that's what they mean by the flat edges.
Like
Good.
the world.
And this horseshoe magnets, it's really just like a bar magnet. I kind of told you that before. But it's like it's bent. So one end is north and the other end is.
Can you
Very
break
good.
those apart?
Who would like to read my first part about magnetic fields? Braylon, loud and proud.
If you want to throw a ball, your hand has to touch the ball. A magnet can push or pull an object without touching it. It does have to be close enough for the object to be in the magnet.
That's the part I was talking about when I showed you the magnet pushing the other one away without touching it. When it has the powers of magnetism, that means that it's part of the magnetic field. Speaking of magnetic field, a magnetic field is the area around a magnet where its force can attract or
Repel.
you can't see a magnetic field, but you can feel where it is. If you bring two magnets close, you can feel them push or pull each other, and you really can. I can feel that they're like fighting each other. You can feel the force. Even when the magnets don't touch,
It feels like
their
a bubble.
magnetic fields interact. If you move the magnets apart, you don't need, or excuse me, you don't feel the push or pull any longer. The magnetic fields are no longer meeting. And I showed that kind of with like our paper clip. Remember when I was here? It wasn't doing anything. What does that tell you?
It doesn't have enough magnetic field.
Right, so am I in the magnetic field yet?
No.
No. How about now?
No.
How about now?
Yeah.
Oh, weird. How about now?
Yes.
So, and that's tricky because this paper clip has a rubber coating. If I go use here's my bobby pin actually. This does not have a rubber coating, it's a regular plain bobby pin. I don't have to get as close. Did you see it slide a little? Oh, I didn't have to get as close to it. Okay, so let's try to make this stronger. See that? So the magnetic field is greater because there wasn't a rubber coating protecting it. Could someone read my caption for this kind of spacey, cool picture down at the bottom here? Riley, loud and proud. Bits of iron.
Bits of iron were sprinkled around this magnet. These bits of iron create a magnetic field.
Very good. If you've ever heard these before, you might have heard someone calling them iron filings because it's literally when they take some iron metal and they file or shave off little pieces. So these are really tiny, fine pieces. Like they can be sharp sometimes, but iron filings are usually like as fine as sand. Turn your page.
Turn your page, turn your page, turn your page.
This is when we peeked out a little bit. Earth is a giant magnet. Iron deep inside the Earth creates a huge magnetic field around the planet. And just like a bar magnet, Earth has two magnetic poles. Who would like to read some more about those poles in this second paragraph? Keegan, loud and proud.
Earth is a giant magnet.
Oh, second paragraph.
Earth's magnetic poles are not at exactly the same locations as Earth's
Geographic.
geographic pole. Earth's geographic pole, the North Pole and the South Pole, are located at the north and south of Earth.
good. Fact check. We call the magnetic pole near Earth's geographic North Pole the magnetic North Pole. And it attracts the North Pole of magnets. Excuse me. It attracts the North Pole of magnets, though. That fact means that it actually behaves like the South Pole, because we know that does north really normally attract north?
No.
No, usually north repels north. So we kind of named them backwards. Does that make sense? Who would like to read about a magnetic compass? River, have you read yet?
No.
Go for it.
A magnetic compass is a tool that shows direction. It uses Earth's magnetic field. The needle of the compass is a magnet that can wheel around. The dip is the north pole of the magnet. It points generally toward Earth's geographic north.
Good. So a compass actually uses magnetic force to show direction. Now, why would we be able to use that to find north and south in Earth? What part of Earth has magnetic properties? What did we learn? Braylon? The North Pole and the... Because way deep down in the Earth's core, if you guys ever see a cutout diagram of the globe, there's like molten lava for one thing in the middle of Earth, but there's also a lot of like iron. And iron does have magnetic properties. So
Is that when you
kind
go
of a fun
mining in
fact for you.
Minecraft, you have to dig down to get iron?
Not really.
And diamonds.
Navigator. Actually, I'm going to skip Navigator for now. Okay, you could read that for funsies, but I want you to also know about electromagnets, because we were talking about magnetism and electricity, and this kind of combines the two. So, a magnetic field forms around a wire if a current flows in the wire. So if you wind the wire into a coil or a spiral, the field is actually stronger. When a current flows in the wire, the coil becomes a magnet. I'm reading here at the top of page 263. It becomes a magnet. The magnet is stronger if you place a metal bar inside the coil. An electromagnet is a coil of wire around a metal bar, such as iron. A battery at the ends of the wire makes a current flow in the... I would like to read my last paragraph here. Dax. Electromagnet electromagnet.
When are we going to get no shoes day?
Very good. Who wants to read this caption for what the girl is doing? Maddie. Very good. Attracts. Yep. Very good. In this top picture, this is an electromagnet, which is a coil of wire around an iron bar. And so then those two ends connected to a battery lets the current or electricity flow through the wire. So did we use an electromagnet to make the paper clips stick to our magnet?
No.
No. What allowed the paper clip to stick to our magnet? Keegan? But what property let it stick to my magnet? Or what force? What property could we say that my paperclip has if it can stick to? The magnetic field is the area that I had to be in to make it stick. But if it does stick to metal objects, or it does stick to magnets, it has the property of magnetism. If I ask you the property, hocus pocus. If an object will push or pull to a magnet, it has the property of magnetism. Okay? So does my pen have magnetism?
Yes.
Maybe.
Yes.
No.
Yes. The metal.
Does my pen have magnetism?
No.
No. Does my paperclip have magnetism?
Yes.
You bet. Does my change have magnetism?
No.
Nope. Does my bobby pin have magnetism?
Yes.
So, for this next bit here, and I'm going to start calling restroom groups. For this next bit, I'm going to give you guys magnets and let you explore the room and try to find objects that do have magnetism. But before we do, I need a scientist to recap. How will you know if it has magnetism? What does that mean? What does it mean if an object has magnetism? What's going to happen? Skylar.
Funny bone and it really hurts.
Sorry, man.
If it has magnetism, then like if you get a magnet, it can stick to.
Very good. The magnet will attract to it. Good. Online friends, obviously I cannot just give you these magnets that we're using here. However, you probably have some magnets at home, like maybe chip clips that stick to your fridge, or magnets on a marker board or something. So ask Mom and Dad if you have a magnet at home. And then you can go and test it on some things, and I'll ask you in your slides what were some magnetic items that you found in your home. Okay? Good luck.